All right, let's dive in, shall we? Today, we're going deep, but not in the way you might think.
No scuba gear required.
Nope, we're talking oil wells, but not just the drilling part. We're getting into the nitty-gritty of how they squeeze every last drop of oil out of those underground reservoirs.
And it's way more high-tech than people might realize.
Exactly. Our sources for this deep dive are excerpts from a technical paper by the Society of Petroleum Engineers, a case study from the Abu Karadig field in Egypt.
It's a fascinating look at how they tackled a tricky situation.
So, picture this. A giant sponge, underground, soaked with oil. That's our oil reservoir. But here's the catch. The pores in this sponge are tiny, super tiny.
Hence the term tight formation. It's like trying to get juice out of a rock.
Yeah, not easy. So to reach more of that oil, they drill sideways, horizontally, like threading a needle through that sponge.
Thousands of feet horizontally, in fact.
Wow, that's a long needle. But even that's not enough, right?
Nope. They need a little extra oomph. That's where acid stimulation comes in.
Acid, like pouring acid down the well.
Well, yeah, but a very specific type of acid. It dissolves some of the rock and creates pathways for the oil to flow.
Like unclogging a pipe, but on a massive scale.
Exactly. Now, imagine trying to do that along a 2,000-foot horizontal section. It's not as simple as it sounds.
Yeah, I bet. How do they make sure the acid reaches the entire target zone and doesn't just take the easy way out?
Well, this is where it gets really cool. They use fiber optic cables that run along the well bore.
Fiber optics, like for internet, down in an oil well?
The same tech, but a different application. These cables provide real-time temperature data. They call it distributed temperature sensing, or DTS.
So they can see where the acid is going, like a live feed?
It's like a thermal map of the well. They can pinpoint where the acid is flowing and reacting with the rock.
That's wild. So it's not a guessing game anymore.
Nope. They can make adjustments as they go based on what the DTS is telling them.
But how do they even know where to start? I mean, planning this whole acid treatment must be incredibly complex.
You're telling me. That's where simulation software comes in. They use a program called Kinetics Matrix to simulate the entire acidizing process beforehand.
So they run a virtual version first.
It's a dress rehearsal, yeah. They can test different approaches, predict how the acid will behave, and then compare the simulation to the real-time data.
A double check to make sure everything's on track.
Exactly. And to make sure the simulation is as accurate as possible, they also use something called production logs.
Production logs. What are those?
They measure how much oil is flowing from different sections of the well
So they can see which areas are contributing the most.
and confirm that the simulation predicted those areas correctly. In this case, the simulation and the actual production logs matched up beautifully.
That's amazing. But how do they actually control where the acid goes? I mean, do they have a little joystick or something?
Not quite a joystick, but they do have diverting agents. Think of them like traffic cops for the acid.
Okay, that's a great analogy. Traffic cops for acid. How does that work?
They used a few different types, actually. One is viscoelastic diverting acid, or VDA. It acts like a temporary plug, blocking off the easiest paths so the acid is forced to go elsewhere.
Like closing off a highway to divert traffic to smaller roads?
Precisely. And then there are these degradable fiber-laden self-diverting acids. They use, well, degradable fibers to create temporary blockages.
So different tools for different traffic situations.
And finally, they use emulsified acid. It's thicker and reacts slower, allowing it to penetrate deeper into the rock.
Gotcha. So by using this cocktail of diverting agents, they can steer that acid where they want it to go.
Like a carefully choreographed dance.
And they can watch it all unfold in real time thanks to those fiber optic cables. But how do they know if it's actually working? I mean, beyond just seeing the acid move around down there.
Well, they start by taking a baseline temperature reading before injecting any acid. Then, after pumping in a pre-flush with hydrochloric acid, they take another reading.
So they can compare the two and see exactly where that pre-flush went. Did it match up with what they expected?
The DTS showed lots of activity in a couple of specific sections. The acid was definitely flowing there.
That's good, right?
Well, here's the thing. They ran a production log after the pre-flush, and it showed only 4 zones out of the entire 1,800-foot horizontal section were producing oil.
Wait, so even though the acid reached those areas, they weren't necessarily the zones that mattered most for production.
Exactly. And that's why the simulation software is so crucial. It helps them pinpoint the specific zones that need stimulation to get the most oil out.
So it's not just about getting the acid down there. It's about targeting it to the right spots.
It's about precision and efficiency.
And this is where that whole data-driven approach really shines.
Absolutely. They're not just drilling and hoping for the best anymore. They're using technology to make smarter decisions every step of the way.
It's fascinating to see how it all comes together, but we've only just begun. There's so much more to explore.
Oh yeah, we're just getting started. Before we dive into that though, let's take a step back for a second.
Mm.
We've been talking about oil wells, but this technology has implications far beyond just oil and gas.
Now, that's a thought-provoking idea. What other applications could benefit from this kind of real-time monitoring and simulation?
Well, that's a question we'll be tackling when we return.
Don't go anywhere, folks. We'll be right back after a quick break.
It really does make you think, doesn't it? The potential of this kind of technology.
It's mind-blowing. But before the break, you mentioned that this tech could go beyond just oil and gas. What else could it be used for?
Well, one area that immediately comes to mind is geothermal energy. Where they inject water into hot rock formations deep underground to create steam.
Right, to generate electricity.
Exactly. And just like with oil wells, knowing how that water flows where the heat's most intense, it's all critical for making the most of that geothermal energy.
So could they use DTS and geothermal wells too, to track the water and see what's happening down there?
Absolutely. Imagine being able to see in real time where that injected water is going, how it's interacting with the rock, if there are any blockages.
It'd be like giving those geothermal plants a constant checkup.
And simulation software could play a huge role too.
Yeah.
They could model different injection strategies, predict long-term performance.
That kind of foresight would be incredible. But what about something like carbon capture and storage? That's all about injecting CO2 underground, right?
You got it. And the challenges are surprisingly similar to what we see in oil and gas. You need to understand how that CO2 will behave underground, make sure it stays put.
So could real-time monitoring help with that? To track the CO2 and make sure it's not leaking?
Absolutely.
Yeah.
It'd be like having a security system for your underground CO2 storage and simulation.
Yeah.
Huge potential there too. They could model different storage scenarios, predict long-term risks.
It seems like this whole toolkit they've developed for oil and gas could be a game changer for so many other applications.
It's all about adapting and applying that knowledge.
Speaking of oil and gas, let's bring it back to our case study for a minute. You mentioned these things called digital twins.
Oh yeah, digital twins are fascinating. It's basically creating a virtual replica of a physical asset, like an oil well or an entire production facility.
Virtual copy in a computer.
Exactly. But it's not just a static copy. It's constantly updated with real-time data from the actual asset.
So it's like a live, interactive model.
Exactly. Engineers can use it to get a much deeper understanding of how things are working, spot potential issues before they become big problems.
That's incredible. It's like having X-ray vision into the entire operation. I've also heard a lot about AI being used in oil and gas these days.
Oh yeah, AI is a big part of this whole data-driven revolution. All this technology generates mountains of data, and AI is perfect for sifting through it all, finding patterns that humans might miss.
So it's like having a superpowered analyst working 24/7.
Exactly. For example, AI algorithms can be trained to spot anomalies in sensor readings, predict equipment failures.
Wow, that's next level stuff. So we've got real-time monitoring, advanced simulation, digital twins, and now AI. It's like the oil and gas industry is going full-on sci-fi.
It's pretty remarkable, isn't it?
Yeah.
But let's not forget about our case study in the Abu Karadig field. What were the actual results of using this high-tech approach to acid stimulation?
Yeah, did they actually get more oil out of the ground?
They did. By combining real-time monitoring with that advanced simulation, they were able to distribute the acid much more evenly.
So less waste, more targeted treatment.
Precisely. The DTS readings and those production logs confirmed it, and it all translated into a significant increase in oil production.
How much more oil were they able to get? Do they give specific numbers?
They didn't specify exact numbers, but they did say the results were economically viable.
So a win-win. More oil, and it was cost-effective.
Exactly. They also talked about the cost savings from optimizing the acid placement, reducing waste,
That makes sense. Less wasted acid means lower costs.
and that real-time monitoring. It allowed them to make adjustments on the fly, reducing downtime.
So it's not just about getting more oil, it's about doing it smarter and more efficiently.
It really highlights the power of data-driven decision-making. This case study is just one example. Imagine the potential if this approach was adopted industry-wide.
It makes you wonder what other innovations are just around the corner.
Speaking of corners, I think it's time we turn one and head into the final stretch of our deep dive.
Don't go anywhere, folks. We'll be right back to wrap things up and leave you with a final thought to ponder. Welcome back. It feels like we've covered so much ground already, from acid stimulation to digital twins and AI.
It's been quite the journey. But as we wrap things up, I want to step back even further. We've talked about how technology is making oil and gas production more efficient. But what about its role in the bigger picture, the global energy transition?
Yeah, how does all this fit into a future that's less reliant on fossil fuels?
That's the big question, isn't it? It's complex, but I think a key piece is looking at how this expertise, these technologies developed in oil and gas, can be applied to other energy sources.
Right? Like we were talking about before the break, geothermal, carbon capture, even hydrogen.
All these areas face similar challenges, right?
Mm.
Understanding how fluids move underground, optimizing production, minimizing environmental impact.
Exactly. And the advancements in real-time monitoring, simulation, AI, they could all play a huge role in advancing those technologies too.
It's about transferring those skills and innovations, collaborating, not competing.
I like that. Harnessing the power of the oil and gas industry to help build a more sustainable energy future.
It's not about abandoning one for the other, but recognizing that the energy transition is a journey, and we need all the tools in the toolbox.
Well said. So, as we wrap up this deep dive, I want to leave our listeners with a final thought to chew on.
Ooh, I love a good challenge. What you got?
How can all these amazing advancements we've talked about, how can they contribute to a more sustainable energy future? There's no easy answer, but I think it's a question worth exploring.
I agree. Maybe the solutions lie right at that intersection of traditional energy expertise and these cutting-edge innovations. It's exciting to think about,
It certainly is. Thanks for joining us on this deep dive. We hope you've learned something new.
and that you'll keep exploring, keep learning.
Until next time.